class. All right, class, thank you very much for allowing me to take your view again. We are going to review this chapter exam. So, here we go. At the beginning, hey, I'm taping. Oh, yes. No, I'm talking to everybody else. Here we go. This review is very, very much what you should study, and any of the homework that you have done if you need extra practice. The idea of this exam, which is mainly formulas, no algebra per se, only computation. So we want to focus first on which ones. Okay, we talk about the polyhedron, which has one face that is repeated for the length of the object. It is solid. And then we have a cross section. That will be part of what we do. But the main things are the volume of a prism, and that is volume equal to going to be the big base times the height. And the base can be a bunch of things. Can be a trapezoid, can be a rectangle, can be all those things except a circle. Then we have the specific one, which is the volume of a cylinder. That is specific because that is the volume equals the base times the height. And here the base is always going to be pi radius squared times the height. That's the specific on that. Cavalieri's principle involves the fact that you can have a cylinder or a prism that is tilted, and still we find the volume with the same object. We are not going to have solids on similar solids. That's just too much work, and more likely you guys will get yourselves confused. So then we have the following, which is the volume of a pyramid. And the volume of a pyramid is the one that we have a fraction for. 1/3 base times height. And here the base can be a lot of things. Hello, I'm glad to see you. Thank you very much. Now we're talking about the volume of similar solids, not on exam. Again, that one you can cross out. So you don't have to worry about that because we're not doing proportional analysis on this one. We're just doing concrete information. All right, but this one is the one you're going to have, surface area of a right cone. Surface area of a right cone. We're going to find this one, the slant height, the L, the volume of a cone, the surface area of a sphere, the volume of a sphere, and of course the axis of revolution on that shape. So those are the primary focuses, and I didn't put all of them down, but I will as I go through it. So here are some examples. The first ones are easy, of course, and that's because you'll have one problem where you just tell me if I slice into a solid, what is the shape that you see from the slice? And on this one, this guy here is a cylinder. So therefore, if I put a perpendicular slice on it, I have a what? Circle. And this would be the answer. If I had a cone and I put a dividing plane on it, I would have a triangle. Yes, nothing hard, but you'll have one problem of this nature. The visual, because it gets you ready for conics. In conics, you go into big detail on that. Now we're talking about a polyhedron as a definition. Polyhedrons have faces, vertices, and edges. So, is the first one a polyhedron? Yes. In fact, it asks us to name it. So this is a what? Pyramid, right? And is this one? No. This that has S edge, but this is not an edge. It is a curve. So this is a no. It is a composite solid. I'm sorry, I interrupted you. All edges and vertices and faces that are two-dimensional, that we can stick it on a graph. All right, that's a good question. Now we're getting to the actual computational aspect. So here we go. This is a prism. In fact, it's a rectangular solid. So in a rectangular solid, and we're looking at volume, we want base times length times height. In this case, these are the easy ones. 4 times 2 times 1.5. We're going to do the math. And we're going to enter. And I think, what did you all get? I got a big number. I'm sorry. I had a number in there and I didn't notice. Let me clear it. And I stuck it again. 4 times 2 times 1.5. And you're right. What you told me was correct, wasn't it? I forgot the times. What did you get? 12? 12. I know. I messed up on it. And this is the important part. You have to tell me its volume. This is a trapezoidal. Because we just want volume. Trapezoidal polyhedron. Yes. On this guy, we're going to have volume is base times height. And in this case, the base is half big base plus little base times the height times the height. And the height here is this. We should put width. I'm going to put width because it's 2. So this one's going to be 0.5 parenthesis 2.3 plus 1.2 times the height of 1.8 times the width, which was 2. Okay, that's what we have. And I'll be careful on that. 0.5 parenthesis 2.3 plus 1.2 close parenthesis times 1.8 times 2. Bam. Got it. And this one is in centimeters cubed. Questions on that? Questions on that? Yes, it's on your sheet. Yeah, it's a 2.3. All right. Now we're going to a cylinder, and this is Cavalari's principle, the second one, saying that we can do them both with the same formula. And in this case, volume is pi radius squared times the height. Volume is pi 3 squared times 10.2. Now we're going to keep pi as part of our answer. 3 squared times 10.2. And I get 91 point. Is in feet cubed. And pi. I forgot the pi after I told you I needed it. Thank you very much. Good. The bottom one is the same formula. So we're going to place it as pi, 5 squared, times the height. So that's 25 times 8, and I think that's 200. And this one's also in feet cubed. Remember the unit of measurements every time we do something. This one is a composite. There are 2 composite examples. You're only going to get one. You understand that, right? Only one on the exam. But we're doing 2 to make sure we see all concepts. On this one, we have 1/2 of a cylinder plus a rectangle, a square solid. All right. So we're going to put this as 0.5, and the cylinder is pi radius squared. And so what we have here is our radius is half, 4, so it's 2. And the height is a length of 4 because it's on its side. And to it, we're going to add 4 times 4 times 4 for the square cube on the bottom. It's not drawn proportionally. All right. So let me get my calculator. And we're going to get 0.5 times 16. 4 times 4. Make sure I got a point. Yep. And that is 8, isn't it? And then I'm going to have the 4 times 4 times 4, which is 64. Can you use what now?
No, I just need.
Okay. Yes.
What's that other 4 next to that 2 square?
On this one?
Yeah.
Oh, this one is how long it is from that circle,
Oh, yeah.
right? Remember, the cylinder is tilted. I said height, but it's tilted this way. We're only using 1/2 of a cylinder. Good questions. All right. Now, this is an exact answer. If you give me a decimal, this is okay. I didn't write down what it was, but you can do that. Mainly, I want pi because, everybody will differ. This one is a subtraction. We have a cylinder minus a smaller cylinder. So we're going to take the big, which is pi radius squared times the height, and we're going to subtract from it the smaller pi radius squared times the height. Is everybody comfortable with that? Everybody see that? Where I got the numbers? All righty then. So we're going to do a little bit math. 8 squared times 11. And on the other side, sorry about that. On the other side, hold on just a second. No, that's better for my eyes. On the other side, I'm going to have 3 squared times 11. So now I'm going to subtract the 704 minus the 99. That's 605. And this guy is in inches cubed. Any questions?
Where did you get like the second pi after the first one?
I'm sorry?
Why are there like 2 pies?
Yes.
The first
because they're both cylinders. They're going to have pi because of the round of the base. Miss Young, did you get that?
Yeah.
Okay. Want to mess anybody up? Super easy. All calculator. So here we have a pyramid. So we know we want the volume, which is the base, times the height. And then we need a what? 1/3, don't we? Okay. So now I'm going to have volume equals 1/3 of 12 times 16 times 7. Is everybody comfortable with that? Everybody see where I got the numbers? All right. Now let's do the math. I'm going to do the 12 times the 16 times the 7, and then I'm going to divide all of that by 3. 4, 4, 8. And this is in meters cubed. Is everybody comfortable with that? Everybody okay? All right. Now we have a little language one, and you'll have at the most 2, maybe 1 less drawing and 2 little word problems. Is that okay with everybody? All righty then. So on this one, it says a pyramid with a square base. So we got something like this. So we got a square base, and the volume equals 120 meters cubed, and the height is 10 meters. All right. So we know volume is the base, 1/3 base. Let me erase that. That's too cramped. Times height. So our problem is going to be 1/3 times 120 times 10 times this. It's going to be solid, right? Because it's a square base. The height is 10. So this gives us 120 equals 10/3 side squared for the base. I'm going to multiply by reciprocal. And when I do that, that cancels a 0. I get 36 equals sides. Take the square root, and my side is 6, the side. The sides equal 6 meters. Everybody comfortable with that? Nothing difficult. All right. So here we have a volume of a composite that has the pyramid with it. So in this case, we want the pyramid volume plus the rectangular solid. Volume. All right. So the pyramid is 1/3 base times height, and the rectangle is base times height. All right. So the base for the pyramid is a rectangle. So I'm going to have 1/3 4 times 6, and the height is 3. Does everybody see where I got those numbers? Everybody understand where I got them? Because this is 6 and this is 4 for the base. Is everybody good? All right. Now the base for the bottom is 4 times the 6 times the 2. And that's because the height of the rectangle is 2. Okay. Now we're going to do our calculator, and we're going to do the 1 divided by 3 times 4 times 6 times 3. 4 times 6 times 2 is 48. And this guy measurements are in inches cubed. Is everybody okay with that? Is everybody good? All right. Well, here we have a cone, and we want surface area of a cone. And the surface area of a cone is going to be the bottom pi radius squared times the lateral. Okay, so and the lateral height is given in this problem. We don't have to solve for it, but on the test you may have to solve for it. Yes, that's an L. This 16 is the L. If it was the height, it would have an arrow here. And that's a good question because you may have that. Okay, it's excellent. All right, so our surface area is pi 8 squares plus pi 8 times the 16. So this is 64 pi. And this is, I don't know. I don't know. 8 times the 16. 128. So when I add them up, I get 192. And this is in inches, and it's squared because it's surface area. Surface area. Is everybody comfortable with that? All right, now we need the volume. And the volume is going to be that 1/3 pi radius cubed. Is everybody comfortable with that? So I'm going to have the 1/3 pi, and here I'm going to have the 8 cubed. All right, so I'm going to have it's 512, and it's going to be 512 over 3 pi. Now, you can give me a mixed number, because my first class asked me. You would get this, that 170.6666. So the volume is 170 2/3 pi, and both of these are in inches cubed, its volume. Either answer is okay. Is everybody comfortable with that? Everybody good? You can stop either at this point, or you can stop prior at this point. Okay, does everybody get that? So long pi is included. All right. Yes. Huh? Oh, I'm sorry. Is everybody good? All right. Now we're going to find the volume of a cone. And the volume of a cone, as we've said earlier, is 1/3 pi radius squared times the height. Okay. Is everybody good? Did I finish that one? Yes. Yes, I did. Yes. Here we go. We've got everything we need. All right, so I know this one is 100 times 13. So my volume is going to be 1300 over 3 pi. Now you can, and this is in millimeters cubed. Now you can divide this if you choose, but you have to make it a good fraction. And either one of these is acceptable. Do not stick pi in your calculator. Very upset. Everybody comfortable? All right. Well, now we want the surface area of a sphere. Oh, yes. Yes, ma'am. I'm good. The surface area of a sphere is 4 pi radius squared. I'm sorry? All right, here we go. So, surface area is going to equal 4 pi 4 squared. Well, this is going to be, this one's easy. This is 16 and 4. And this is in feet squared. Right. Now this one has a diameter instead of a radius. So we're going to have 18.3 divided by 2 to find the radius. And this is 9.15 equals the radius. Is everybody comfortable with that? Now we need the surface area. And that's going to be 4 pi times 9.515. Come on, pencil. Squared. And we're going to stick these numbers in the calculator. Or meter squared, whichever you want. All right. Is everybody comfortable with that? Nothing hard yet. Want the volume of a sphere? That's 4/3 pi radius cubed. Don't have a height. So our volume here, okay, we're going to have 22 divided by 2 for the radius. 11 is the radius. Is everybody good with that? So we're going to have 4/3 pi, and radius is cubed. Oh, I did that. So the radius is 11 cubed. Here we go. Uh, 11 cubed is 131. 1331 times 4 is 5324 over 3 pi, or that number divided by 3, which gives us 1774 and 2/3 pi. And both of these are volume, so they're in cubic yards. Questions on that? Okay. This one has one step that we need to get to prior to working the problem. We're given circumference. Well, we recall that circumference is 2 pi r. Therefore, we're going to have 20 pi equal to 2 pi r. I'm going to divide by the 2 pi, and I get 10 is r. And now I can use my volume formula and insert our values. That's 1,000. So I'm going to have 4,000 thirds pi, and this one's in centimeters cubed, or I could divide it out. I'm going to get 1,333 and a third centimeters cubed. Either answer is okay. Everybody comfortable with that? Either answer. But the pi must stay. Oops, I left off the pi on this guy. Sorry about that. There we go. Alrighty then. Now we're at our modeling. And you read for content when you're doing anything and figure out what has to happen. In this diagram shows the dimensions of a block of ice. Ice has a density of 9,200 grams per centimeters cubed. All right, find the mass. So we know density equals mass over volume. The problem is the volume has to be in centimeters. So our first step is to change or convert inches to centimeters. So we have to know that 1 inch equals 2 and 5/5400 centimeters. So we know that. So we're going to have the 3.5 inches times, and I know 1 inch equals 2 and 5/5400 centimeters, and that way we can cancel the inches. And then we're going to do that next one, which was 7.5 inches, and we're converting to centimeters. This means times. Again, we cancel the inches and convert to centimeters. And then do the last one. And again, those cancel, and everything else is by calculator. So here we go. And in our calculator, we're going to put 3.5 times the 2.54. We're having the 7.5 times the 2.54. Here we have the 11.5 times the 2.54. In the first class, I went so fast that I left off one of the decimals. So now our second step is to calculate volume. So we know that volume is the base times the height. So we're going to have our 29.21 times our 19.05 for our base times the height, which is now 8 and 89 centimeters. So we're going to get our calculator out. because that is just calculator. I'm sorry about that. Right, and we're going to multiply this stuff. Oops. I'm going to try to keep it in the, all right, that's good enough. So I'm going to have the 29 and 21 hundredths times the 19 and 5 hundredths times the 8 and 89, oops, 89 hundredths, and enter. And we'll get this number. I'm gonna round to 2 decimal places, and this is in centimeters cubed. All right. So our last step is finding the mass. Said above that density times volume equals the size of the mass. So this is 0.92, and we're multiplying by 494,684 should give us the mass. Now it's calculator time. Decimal 92 times 4946 decimal 84, and I get, and we're going to just use the whole number and label grams because that's what it was in. Questions? Questions? Everybody good? All right. Now, I'm going to skip the apple. You'll just look online for the process because I want to get to this. All right. This is our axis right here. This is our axis. And that's where we're rotating it around. So if I'm rotating around, then I'm going to have at the halfway mark, I'm going to have this. All right. And as it circles around, I'm going to have a what? Cone. And they want us to calculate the volume, surface area, and volume. All right. So the surface area for a cone is, I wrote that down, make sure I got this correct. No, I didn't. Surface area of a cone is 4 pi r squared, I think. And let me find, let's see, it's on 5. It's not it, 4. There it is. Surface area, oh, I got that wrong. I need the lateral. Nobody told me. I need the lateral. I got the wrong one. Okay, got it. That's of a sphere. Pi radius squared plus pi r and the lateral. So on this one, I have to first calculate the lateral. By Pythagorean theorem. And so I'm going to have 12 squared plus 10 squared has to equal my L squared. This is 144, and 100 equals L squared. So that's 244 equals L squared. All right, and it's going to be an approximation. Yeah. She shakes. It's not getting bigger. There we go. Thank you, calculator. All right. So I'm going to put in a second square root of that 244, and I get 15.6. I'm going to just do one decimal. All right. So now I have the L, and I can now do the surface area. And on my pi radius squared, my radius is 10. And that one was 15.6. So I'm going to do it by calculator. Oh, this is 100 pi. And that guy there, is 156 pi, 256 pi, and this is in square. I don't have any more on it. Now, the volume base, and it's a third. 1/3 base times height. And we have a circular base. So pi 10 squared times the height. All right. This is 100 times the 12. And this is in units cubed. All right. We only had one left, and this one is a rectangular. And this one's even easier, solid. And so we would have to, in this case, because we're doing it across, and we would see that. And this is the base times height. All right, I'll check online for the ones I did not get to complete. Is everybody comfortable with that? Thank you. Thank you very much.